That go? Good. Should have been a ton of review. Okay. You've done direct variation prior to this. Last year you studied it, but we need to bring a refresher course, and this is what I'm going to tell you. So many times people are like, I don't need to show all the work that Miss Hoff does. And I think some of you have already discovered this year, that like she shows us a process because we're going to get there. Like, don't try to shortcut this. And this is one that is specifically more so on the back side of this worksheet. The front side you'll be pretty okay on. But on the back side of this, making sure that you don't shortcut. If you follow the process, you'll be good. Okay? Direct variation is described by an equation in the form y equals mx. Y equals mx. Sometimes they'll say y equals kx. That means the same thing. K and m are sometimes interchanged. The equation illustrates a constant rate of change, and k, or m, is the constant of variation, also called the constant of proportionality. 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 Y is always going to be in your equation. X is always going to be in your equation. What you're looking at is the K or the M, the constant of proportionality. Name the constant of variation for each question, then find the slope of the line that passes through each pair of points. So if I gave you the equation thinking about y equals kx, if I give you the equation y equals negative 4x, what's my k value? Negative 4. The coefficient of x is my k value. So my constant of proportionality is negative 4. Now they say find the slope. They give us 2 points, yes? Let's find the slope. What's the y value you want to start with? 4 minus 0 over negative 1 minus 0. 4 minus 0? 4. Negative 1 minus 0? 4 divided by negative 1? Negative 4.
So how did you get like k equals 4 like at the top?
How did we get k equals 4? Who can help? Who can tell him that? It's your coefficient of x in that equation they gave us that I highlighted right here.
Oh.
Simple. Don't overthink that one. 100%. Okay. So in this one, your equation y equals 1/2 x. What's your k value? 1/2. You guys find your slope. Miss Hoff, they only gave me 1 point. What's the other point? 0, 0. Okay. Find your slope on your own. What'd you get? 1/2. Jackson, say your statement earlier. Say it again. Couldn't K be M? Yes, I wasn't ignoring you. I wanted you to see this one too. K and M are interchangeable, and I kind of gave that away when I first wrote that equation down. But your constant of proportionality, or the coefficient of x, if y is by itself, is your slope. Now, what else do you notice about these two graphs that they have in common? They both go through the origin. That's also a huge part of direct variation. So what do you notice about the slope of the graph and the constant of variation? K and M are the same. Your constant of variation, or in other words, your slope, are interchangeable. And then I wrote, what do you notice about the y-intercepts, but we just mainly talk about what do you notice about the graphs. They both go through the origin, through 0, 0. Every single problem today that you have to graph will go through 0, 0. Every single problem, because they're all going to be direct variation equations. So they're going to ask us to graph this line. Y equals 4x. Y is by itself equals 4x. Almost looks like y equals kx, correct? So in our case, our k is 4. But we also figured out k is the same thing as m, which is 4. Every single direct variation equation goes through 0, 0. So we're going to put a point at 0, 0. It goes through 0, 0. Then we have to remember what slope means. And slope, I know it's not simplified when you write it over 1, but it's crucial that we write it over 1 because slope is rise over run. And when I say rise, what two directions does that number guide us to go? Either up or down. And run tells us to go either left or right. And how do you know if it means up or down or left or right? Negative is positive. Perfect, perfect, perfect. Great answers, okay? So if I have a positive 4 in my rise, what's that telling me to do? Go up 4. Excuse me. If I have a positive 1 in my run, I'm going right 1. So from 0, 0, go up 4, right 1, put a dot. Now, because we don't have the beauty of Alex on our sheet of paper, let's do it again. From that point, go up 4, right 1, put a dot. Now, that's great to be able to draw all of these points here, but what if I need to get points down here? What could I do? The opposite. Instead of going up, I could go down. Instead of going right, I could go, so I could go down 4 and left 1, down 4 and left 1. Now, on Alex, do you have to put that many points? No, you just need 2 because it's got that beautiful line tool. But I just want to discuss, just so you remember, you can go the opposite directions. Plus, it helps us draw a prettier line on our piece of paper. So our next equation is y equals negative 2x. Y is by itself, so what's my k? Negative 2, which in other words means my slope is negative 2. Where do I start? 0, 0. I'm always going to start on the origin. Now, with the slope of negative 2 over 1, what's a negative 2 rise tell me? I'm actually going down 2. Now, is my 1 positive or negative? Positive. Good. So I'm going to the right 1. But Ms. Hoff, there's a negative sign right here. Doesn't that go with the 1 too? Why not? Because if you had 2 negatives, it would be a positive. Very good. Excellent job. Go down 2 and right 1. Down 2 and right 1. Or you could go up and left. Up and left. Nicely done. It's a terrible line. Forgive my computer screen drawing. Beauty today, you go through 0, 0.
Every time?
Every time today. 100%. Every time today. Every time today, you're going through 0, 0. All right. Here's where we are that Ms. Hoff has a process. If you follow this process, you're going to get this correct. You attempt to make shortcuts, chances are you're going to make a mistake. If a relationship between the values of y and x can be described by a direct variation equation, then the phrase y varies directly as x. The key phrase really being varies directly. Whatever they talk about before that phrase is always going to be your y value. Whatever they talk about after that phrase is always going to be your x value. So the questions are going to look like this. Suppose y varies directly as x. Y is 12 when x is 15. Write a direct variation equation that relates x and y, then find y when x equals 2. On ALEKS, these two statements are two separate boxes. So on these problems, you're going to have two things. Okay? Now, if y varies directly as x, we have a direct variation equation. What is the direct variation equation we just talked about? Y equals kx. That's where we start. Y equals kx. Now we use our first sentence they give us. Y equals 12 when x equals 15. Replace those letters with those numbers. Y is 12, x is 15. I don't know what k is, so I'm going to leave it as a k. And that looks really goofy, right? With the k in front of the 15. But really, what operation is happening there? Multiplication. So to undo multiplication, I divide. In this case, I'm going to divide by 15. Now, without even typing it into your calculator, you should know that 12 divided by 15 is a decimal. Why? But why do you know it's a decimal?
Because it's not a full fraction.
How do you know that?
Because 12 over 15 is a whole. It's 12 parts.
And how do you know that? You're onto it. Keep going.
Geez.
How do you know it's not a whole?
It's not in the percentage.
Your numerator is not bigger than your denominator, right? So you know it's going to be under 1. Do I want a decimal? No. So what do I do to this? Simplify. Divide by, what'd you say? 3. Okay. So if I divide a 3 out, I end up with, say it again, 4/5. Now that's not an answer. That's going to help us write a direct variation equation. A direct variation equation is going to have a y, it's going to have an x, and we have to figure out what k is. Well, you just figured out what k is, right? So for this problem, instead of writing y equals kx, what do I write now? Y equals 4/5 x. That is the very first answer that you will write in. It's an equation. You're going to have a y. You're going to have an equals. You're going to have an x. What changes on every problem is the k value. So then part 2 says, find y when x equals 2. So now we take our equation, y equals 4/5 x, and they want us to find y when x equals 2. So what do I do now? Substitute in 2 for your x. Y equals 4/5 times 2. Now, if I'm going to take 4/5 times 2, what should I do to 2? Put it over 1. Can I simplify diagonally? Nope. So I multiply across, top times top, bottom times bottom. Y equals 8/5. That's part 2. People are like, oh, it's so much work. It takes less time because you get it right on the first try. I promise you. Okay? We're going to repeat the process. Just the same exact thing. Suppose that y varies directly with x. Y is 2 and x is 16. Write a direct variation equation that relates x and y. Then find x when y equals 2. Okay? What do I always start with? Y equals kx. Look at the information they give you. What are you replacing? Y and x. Y is 2. I'm going to leave k a k. X is 16. I'm really trying to solve for k, so I should divide by 16. What does k equal? 1/8. Is that my answer? No. What is my answer? Y equals 1/8 x. Because it says write a direct variation equation, so you know you're going to have an equal sign. Part 2, take the equation you just wrote, y equals 1/8 x. It says find x when y equals 2. What do I do on this one? 2 equals 1/8 x. We got to replace y with 2 this time. Now it's like having an equation in chapter 2, right? How do I solve for x? Multiply by, which is 8, or 8 over 1. So x is actually 16.
Could we figure it out because y was our.
Oh, I was probably supposed to change that number. Well, there you go. I think I was supposed to change that number. Like to a 3 or something. Good observation, though. Whoever wrote these notes should really work on that. Question?
Part 1 of that, how did it go from 1/8 equals k to y equals 1/8 x?
Somebody help him out.
K is 1/8 and then KX, so then you just plug it.
So what they want is a direct variation equation. We're finding k by plugging in our x and y that we know, but they're asking us what's the equation that created these two. So we find our k value and then create the equation. It's always an equation on that first one. So now we're going to use the same process, but we're going to talk about Newton's second law. According to Newton's second law of motion, the force acting on an object varies directly with, that's a really key phrase, the object's acceleration. Suppose a force of 20 newtons results in an acceleration of 5 meters per second squared. If the force is changed to 12 newtons, what will the object's acceleration become? Because it gives us varies directly with, if we go back to the top of your page, we talked about whatever is in front of that phrase is your y value. Whatever's behind that phrase is your x value. So in our problem, what's our y value? The force. Very good. Our force is our y value. Thank you for not saying object. So many times I say, what's our y? And they're like, object, because it's right in front of that phrase. So thank you for reading. Our force is our y value, and our x value is acceleration. We're going to follow the same process as before, but they didn't say x equals this and y equals this. They tell us a force of 20 results in an acceleration of 5. So in our y equals kx, how do I know what number goes in for y and what number goes in for x? Because we labeled them. Our force is y. In my highlighted, what's my force? 20. K is going to stay at k. What's my x, or in other words, my acceleration? 5. How do I solve for k? Divide by 5. K equals 4. So my equation is really y equals 4x. Then it goes on to say, the force is changed to 12 newtons. Okay. So which number is changed to, or which letter is 12 now? Y equals 4x. So I really need to replace y with 12. To solve, I divide by 4. X equals 3. Now, does that make sense? The force went from 20 to 12, so it went down, right? My acceleration went from 5 to 3. Varies directly. When one goes down, the other goes down. When one goes up, the other one goes up. Thatcher.
Could we have just done like what we did yesterday, where it was like 20 and then like 5, so that it was like, you know, that like chart thing or whatever, where it was like slope? Couldn't we have like,
That's what we did when we found K. You'll want to set this up as a direct variation because they're not always going to ask you about force. They're going to ask you sometimes about acceleration. The last part about today is just being able to look at an equation and decide if it's direct variation. Direct variation is y equals kx. or y equals mx. Y is by itself, or when y is by itself, all you have is a number or your k times x. So the equation on the left, 6x equals negative 7y minus 6. Why is it not a direct variation? Could I get y by itself? Could I move y to the other side? Why is it not direct variation? She says it's not a direct variation because I have a minus 6. 6 doesn't have a variable. Do we have any number over here that's not with a variable? No, don't overthink this, people. I can manipulate this to get y by itself, agreed? We could add 6 to the other side. We could divide by 7. That's fine and dandy to get y by itself. But your equation is going to be very simple. Y equals a coefficient times x. If you have anything that is not with your x, it is not a direct variation. Not a direct variation.
So if anything doesn't have a variable next to it, it's just not a direct variation.
I may have just said that, yep. 4y equals 20x. Is this a direct variation equation? Yes. Then it says, if it does, find the constant of variation and write it in simplest form. To find your constant of variation, this is where you got to get y by itself. How am I going to take this equation 4y equals 20x and get y by itself? Divide by 4, y equals 5x. So there's my equation in simplest form. My constant of proportionality then, or my k, is 5. Y equals kx. Y equals kx, or y equals mx. Definitely going to have work to be shown today. So make sure you get work paper. If you are going to be gone for football on Tuesday, I need to see you right here. The rest of you can go to work.